So I'm Laurence Moroney from Google. I work on Firebase as a developer advocate, and I also work on Google Maps as a developer advocate. My Twitter handle's there, so if you have any questions, just ping me on that, and I need all the followers I can get. So I'm here today to talk about Firebase, and Firebase, the product that we've been working on, and particularly a lot of the user research that we've been doing at Google on the habits of highly successful developers, and why we built Firebase the way that we built it to help developers be successful. So first, I'll start with a couple of statistics. This statistic, 51%. Believe it or not, this statistic is the number of mobile developers, according to a recent survey, this was Q4 2016, who fall below the poverty line in earnings, where the poverty line is defined as $500 a month or less. 51% actually fall below that line, and unfortunately that number is growing. In the first half of 2016 it was 50%, in the second half it was 51%, and we're seeing it's growing slowly, but we're actually seeing that accelerating. The second number I want to share is 29%. And 29%, this is the percentage of developers who are above what we call the rich line, and that's earning $5,000 or more a month off of their mobile app. As we can see, it's a lot smaller than the ones who are below the poverty line. So what we wanted to do is say, okay, when we're looking at developers like this, and we're looking at how much they're earning, the shock that we had was not only are most of them below the poverty line, the vast majority of them are way below the poverty line. It was about 39% were actually earning less than $100 a month off of their mobile app. So we said, okay, what can we do to fix this? This is a trend that we've been seeing for some time. What can we do to fix this? And what are the habits of the folks on the right-hand side of this diagram? What are the habits of the highly successful developers? So there were a number of them, and one of them was actually the fact that everybody in the 25K plus bucket targeted all three platforms, Android, iOS, and the web. Now, we speak to Android developers all the time who absolutely love Android and maybe are cats and dogs when it comes to iOS, and we speak to iOS developers all the time who absolutely love iOS and who may be cats and dogs when it comes to Android. And then we speak to mobile web developers all the time who don't like either of the other two. And but we realized that, every single one in the top bucket targeted all three platforms. It becomes a must if you want to be a highly successful developer to target the web, to target iOS, and to target Android. So with that in mind, we started building a few years ago something that we called the Google Mobile Platform. But then we launched it last year, and we launched this thing called Firebase. So usually at this point when I'm talking about it, people go, wait a second, you didn't build Firebase, you bought Firebase. And that's partially true. When we made the acquisition of Firebase, Firebase was this real-time web-based database, NoSQL type database, and this really cool authentication scheme behind it. And that came as an acquisition, I think it was in 2015. And we realized that as we're building out our mobile platform and as we're building out this suite of tools to help people be on the right-hand side of that diagram, that the Firebase database had to be a part of that, because it was exactly what we needed to be a part of that overall strategy. So then when we launched this mobile-first strategy, this set of technologies that will help build highly successful developers, we wanted to keep the name Firebase because we didn't want it to seem that like Google had bought Firebase and swallowed it and put it into something bigger. So we released Firebase, and this is what Firebase looks like today. And the strategy around Firebase is that we realized that for somebody to be successful, they need a suite of services that will help them build better apps. So a number of things that help them as they're developing an app. Now, these aren't designed to replace the SDKs that you may be using, like the Android SDK or your iOS SDKs, be it in Swift or Objective-C, or your web SDKs. These are designed to enhance them. So if you need a back-end database, for example, we have a real-time database, which was the original Firebase. If you need authentication, we have the Firebase Authentication, but we've built a number of authentication technologies on top of that for a federated identity, etc. But not only do we realize that developers, in order to be successful, needed technologies that will help them build their apps, they also need technologies that will help them grow their apps. A lot of time as a developer builds an app and launches it, there's a bit of a marketing budget that goes into the launch, and you build the app and you put it in the Play Store or you put it in the App Store, you put your marketing behind it, you do the launch, you get a whole bunch of installs, then 3 weeks later you get nothing. And then usually there's no marketing budget to keep it going, and it's very, very hard to keep growing your app and keep your population going. So we realized that there are a number of technologies that can be used, and there are a number of strategies that can be used to help grow the application. So we built these technologies and we put them into Firebase. As you can see at the center of the circle is analytics, and so you may be familiar with Google Analytics. The same team that built Google Analytics then built this lightweight Firebase Analytics, and the idea is analytics ties everything together, and almost all of these technologies use analytics, and I'm going to talk about that in a little bit more detail. And then finally, of course, you want to earn from your hard work. So there's two ways that you can typically earn from an application. Number one is you sell the app. Number two is you put ads in the app. So we have the Play Store that you can sell the app through. Apple have the iOS App Store that you can sell your app through. But we also wanted to put advertising, wanted to give you a facility to put advertising that's targeted to your users. So I always like to tell the joke that if you're building a sports application, you don't want to have like commercials for diapers, sorry, nappies in this country, in your sports application, and vice versa. If you're building an application for moms, they probably don't want to see adverts for, sports and football and baseball and all that kind of thing. You really want to have targeted adverts, because if you have poorly targeted adverts in your application, that will turn people off your application. So we have this, our advertising technology, we're continuing to finely tune it to make sure that it works very well for your apps. But first of all, I'll talk about analytics. So I'm a very lazy developer, and I like to write as little code as possible. And the analytics, we designed this with people like me in mind, and I used to be a development manager. Anybody here a development manager? Nobody? Oh, wow, okay. There's usually a few in the audience. And so as a development manager, you usually have one of those meetings where it's like the developers are saying, well, we want this set of analytics to be measured. And then the marketing people are saying, we want this set of analytics to be measured. The sales people have quotas. They want this set of analytics to be measured. The business people, want yet another set of analytics to be measured. And typically, it's like you can't get them to compromise. It's another instance of cats and dogs that you can't get them to compromise. They all want their own analytics, and it comes on the poor development manager to say, well, we can't build all of these. And you usually don't end up building any of them. So with this in mind, with analytics for Firebase, we said, let's see if we can put analytics into Firebase that requires 0 lines of code. And that's what Firebase Analytics is all about. So in Android, you have a build.grado file. You put a single line of configuration into your build.grado file, and you get a whole bunch of analytics for free. And that's for free as in cost. It doesn't cost you anything. And of course, for free as in it doesn't take any time to build it. You just add this one line to your build.grado file. So you think about all the typical events that will happen in an application: open, close, install, uninstall, activate an activity, move off an activity, make an in-app purchase, all of those kind of things. All of those common analytics are actually gathered for you and are put into the Firebase console where you can access them and you can analyze them, and it doesn't cost a dime. And of course, like I said, it's very easy for you to build into it. Then, of course, if you have custom analytics that you want to gather, like maybe you're building a game, and in this game you have like a boss on level 3 who's really hard to defeat, and people are quitting your game and uninstalling your game as a result of that. Well, we can't figure out that it's, your boss on level 3 is the problem, so you'd have a custom analytic that you can build and you can design into it. And then that does take a little bit of coding, but it's still free of charge. Now, here's an example of some analytics that we've gathered. So this was using just the build.gradle that I mentioned earlier on, just adding a single line of configuration to it. And a Googler wrote this game called Bingo Blast that we released last year at Google I/O. And we gathered some analytics off of it. And one of the things I just wanted to call out is, as you can see here, we have both the iOS version and we have the Android version of it. And if you look at the 2 boxes on the top right, that's showing the monthly active users and the in-app purchases. So on the Android one at that time, the monthly active users was 22,700, and on the iOS one, the monthly active users was a little over 5,000. So we had 4 times as many Android users as we had iOS users. Now, typically, there's an urban legend that iOS users spend more money. We actually confirm that here. Right, so even though we made, we made $3,000 off of 5,000 iOS users, we only made $2,000 off of 22,000 Android users. So even though we're all at Google really passionate about Android, had we only built for Android, we wouldn't be on the right-hand side of the diagram that I was speaking about earlier on. This brought us above the $5,000 barrier because we targeted iOS as well. So that's analytics, and you'll see as I talk through a lot of the features for development that a lot of them are driven by analytics. So let's look at some of the ones for developers. The first is the Realtime Database. Anybody familiar with it? Anybody use Firebase? Okay, cool. A few. So it's a NoSQL-based database. And it's cloud hosted, it's cloud based. But the main thing about it that I like to talk about is that it's event driven. It's not the typical thing we have to think about writing and reading and all that kind of stuff. When you change values in the database, an event will fire in your application. It will fire in any application that is, reading that node in the database. And you handle events upon data changes. You don't write any kind of a back end. You don't write any kind of a data access tier. You don't need all of that, code, all that middleware code. You have code within your app, within your mobile app or within your web app that talks to the database, that subscribes to a node within that database or a set of nodes within that database. And whenever any changes or anything that you're interested in happens in that, an event will fire, and then you write code to handle that. So for you to maintain and manage your database, all you have to do is write your mobile or web app. Now, what this gives you is synchronization across devices. So, for example, we live in a multi-device world, and many of us have a laptop, have a tablet, have a phone, maybe have a watch that are smart. And so the idea is that if we want data synchronized across all of these, because it's an event-driven thing, we're not thinking in terms of polling for database or anything like that. So if I have, for example, I'm using my mobile app, and I change the state of the database, and I want that to be reflected on my tablet, then if the app is listening to that node in the database, an event will fire, the tablet gets synchronized. And as a result, you get this effectively for free, this automatic synchronization. In addition to that, it works offline. So the idea is that, and particularly in a mobile world, we're moving from network to network constantly. And so then we go from a state of being connected to a state of being disconnected. And the idea is that built into Firebase and built into the real-time database is this disconnected state. So if I have two devices, one device is connected, the other isn't. If I update the database from the connected one, once the disconnected one is synchronized and comes back online, those events will fire, and then the disconnected one will be able to update its state automatically. Next up is authentication, and this one to me is really interesting because the number one reason why a lot of people blow through their budget in development when they have an authentication in their app is that they underestimate how much time it takes to build and secure a system when you're keeping other people's identities. So it's incredibly difficult, and it's getting more and more difficult. So if you're keeping other people's identities, and if you're storing that data somewhere, the amount of security that you need to build in is incredible. So one of the things that users always gave back to us was that, please do this for us, right? You have Google sign in with Gmail, let us use that, but not all of our users want to use Gmail. Some want to use Twitter, some want to use Facebook, some want to use GitHub. And so can we have a free API, an easy-to-use API with like drop-in widgets that you can use to sign into all of the above, and then we don't have to think about keeping the user's identity. Facebook will provide us with their name and their picture, or Twitter will provide us with their name and their picture, and a single API to handle all of that. And that's why we built Firebase Auth. So the existing authentication that was in Firebase, we enhanced with the stuff that we were doing. We had something that was called GitKit, the Google Identity Toolkit, and we enhanced it with that, and Firebase authentication then fell out of this. By the way, one thing I forgot to mention, when you see all this suite of products, you can use any of these independently. It's not a use all or use none. You can use any of them that you like, and most of them are actually free of charge. Auth is one of those that's free of charge. Okay, next up is cloud storage. So a lot of applications require file storage. Maybe you're building a photo sharing app, or maybe you're building some kind of video editing app or something along those lines. And to be able to do that, you need some kind of file storage. And in some ways, the challenge of this is very similar to Auth, because you're storing data on your user's behalf, and you want to make sure that that data is secured. So cloud storage for Firebase will allow you to do that. It's an API that will allow you to store files within Google's cloud. And because it's integrated with Auth, you can have files separated based on user identity so that user A can't see user B's files, those kind of things. But the main part of this that I find really interesting is handling poor connectivity. So think about all the code that you would typically have to write if you're building something that has file storage. And say it's a large file and you need to manage uploads and downloads of those files in times of poor connectivity, where a file can be where your system can be disconnected, and as a result, all that code that you have to manage the handshaking, if you have a gigabyte file and you disconnect after 999 megabytes have uploaded and you don't want the user to start again, that's really user hostile. That's a doorknob instead of a door handle. So the whole idea is, like with the Google Cloud Storage, we have that connected, we have that logic built in for handling that communication, and then cloud storage for Firebase's APIs built on top of that will allow you to do cloud storage and handle poor connectivity. Next up, and one of my favorites, is Firebase Cloud Messaging. So Firebase Cloud Messaging, as of last November, it handles 1 trillion messages per week. And all of those, it's something like 98% of those messages, when delivered to connected devices, are delivered in less than 500 milliseconds. So it's a huge, huge, huge infrastructure, and it's there for you to take advantage of for free. So the idea is that you can build notifications, again, web, iOS, or Android, so that your users can receive notifications, so that you can send notifications to them. And, but more importantly, and going back to analytics for a second, you know, the worst thing that you can do for your users is notification spam. How many times have you installed an application, you've used it once, then you receive constant notifications from an application, then you turn the application off and uninstall it? That's exactly the behavior we're trying to avoid, but we want to give you the ability to have notifications in there, but then using analytics to actually target those notifications effectively. So for example, if somebody used your application once, never used it again, you have an analytic for that, and you could say, maybe deliver 1 notification to them and no more. If somebody, or another classic example is maybe you've built an e-commerce application and a person used to shop regularly on your e-commerce application and now they're not shopping anymore. They made a whole bunch of purchases, but they haven't made a purchase in the last 3 months. You could build an audience of those people with analytics, and you could target those people specifically with a notification saying, hey, come back to the app and we'll give you a 10% discount, something along those lines. So that's where analytics is tied into it. And then the last part of the versatile messaging targeting is we have a concept called topics. So the idea is that if you build an application, and the one example that I like to use is, say you're building an application for public transport all over the world, and if your user is in London, they might want to receive notifications about delays in the underground in London, but they don't want to receive notifications about delays in the underground in Tokyo. But then if they travel from London to Tokyo, they want it to be vice versa. They don't want to be receiving notifications about London. They do want to be receiving notifications about Tokyo. And then the idea is you can build something called a topic. So you could have a topic for underground messages in Tokyo, a topic for underground messages in London, and then subscribe your user to them accordingly. So then when you send a notification to that topic, only the users who subscribe to that topic will receive them. That also helps us keep the infrastructure really fast, because if every message went to every user, it would be harder for us to manage the overall scale. So the next part of it is remote config, and this is one of my favorites, and it's a very misunderstood technology, but it's really cool. And the idea behind remote config is that it allows you to put variables on the server and then have the values of those variables set through analytics. So for example, if you're building an e-commerce application, and in your e-commerce application you want to give a standard discount. So every user gets a standard discount of 0%. But then you say, okay, you know, not enough women are using my application to buy stuff. So using analytics, I say, if the user is a woman, let's give them a discount of 20%. So now when your application reads the standard discount value back from the server, because this user is a woman, she meets the analytics needs of, like, it's a woman, she gets the discount back of 20%. And now suddenly you get lots and lots more women using your application. Maybe you have too many of them and you want to dial it back, and instead of giving them 20%, you want to give them 5%. So then the idea would be that, how would you do that? You'd normally have a whole lot of if-then code in your app, and you'd have to ship a new update to your app. But if all this is done on the server side, without you writing any code, that you just have a variable, a remote configuration variable on the server that's triggered by analytics, when you want to change that standard discount so that, in this case, like women, you're changing it from 20% to 10%, then you would just change that on the Firebase console, and the app would update automatically with that value and that state value. So little things like that, you know, can really make a big difference for your application. A lot of times people think remote config is just for A/B testing, but you know, thinking about setting values based on analytics is, to me, makes it really exciting, and it gets rid of a lot of that if-then code that you would typically have to write and ship and update in your application. Another use for this I found was if you do things like YouTube or Google Maps or anything else that requires an API key, you typically have to ship the API key in your application. Somebody can then, you know, decompile your application and pull your API key out of it. And if you're using an API that has like a quota, somebody could conceivably steal your quota and effectively give a denial of service against your application. you could put your value, your API key value, in a remote config variable. It never ships in your application, and it only reads it at runtime, and then it's reading it across an HTTPS, so it's a lot harder for it to be stolen. So there's a game that I've been working on that I built that uses the YouTube API, uses Google Maps APIs, all that kind of thing, and headache gone for me because I can just store those API keys in remote config. So next up is Test Lab for Android. So I'll do a question. How many people here have a Pixel XL? Nobody. I usually get that answer. I don't have one either. I've been trying to get one, but they're really hard to find. But if you're building an application and you need to test it on a Pixel XL, what do? You know, you might emulate it, and yeah, it's like you can do stuff like that. But then if it's, you spend all the time to set up an emulator for Pixel XL, but then what if it's a Samsung Galaxy 8? How do you test it on that? You got to set up another emulator for that. Or what if you're a developer in a country where that phone isn't actually physically available? So even if you did want to get it, you can't. We have a lot of developers in China, for example, who build applications for the global market, not for the Chinese market, and there are devices that they need to be able to test on that they can't test on because they physically can't get that device in China. So the idea behind Test Lab for Android is that we've built a data center with just about every Android device imaginable, either in a virtual form or a physical form. And you upload your APK to this data center, and we'll do a set of robo tests for you. So basic tests like open, close, install, uninstall, you know, click here, click there, move to this activity, those kind of things. Or you can design custom tests yourself. So then you would upload the script for these custom tests, and it would run the test for you. And then it sends back a bunch of screenshots. It sends back like a stack trace whenever there's a failure, those kind of things. So this is one of the things that isn't free in Firebase, by the way. This one does have a cost associated with it. But we found when working with users that the cost associated with this is a lot lower than if they were to, you know, to test on all these devices themselves, and it's a lot better than sending it out into the world and not testing on every device. So another favorite of mine is crash reporting. The number one reason why your app gets negative reviews in the Play Store or the App Store is that it doesn't work out of the box. You just take a look at any app and you'll take a look at the one-star reviews for that app, and it's always, it crashed, it didn't work, I spent all this time downloading it. And so crash reporting, what it does is that if you link that library, you don't write any code, if you link that library into Firebase, then whenever your app experiences a crash, it will upload the stack trace of that crash to the Firebase console so you can investigate the reason why that crash happened. A few moments ago I was talking about a game that I was developing, and I was building it. It's like an interactive game where there's a character trapped in a parallel universe, and it's a whole bunch of pre-rendered animations of this character talking to you, and I use the YouTube API to render those on the screen, and then there's interaction with that character to navigate to different videos. And but I was doing the talk, and I needed to demo this game in Japan late last year, so I thought it would be really neat if I re-rendered all the videos using a Japanese voice actress, so then I could switch so that instead of like them hearing it in English, the character would actually speak in Japanese, and we could talk over and back with the character in the game in Japanese. And I was testing this from my office in Seattle, and I sent it to a number of people in Japan, and none of them could launch the application. It just crash, 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 crash. And I was like, darn it, I have to present this at a conference. Am I going to fly to Japan early to debug this thing? Or will I put crash reporting into it? I put crash reporting into it, they ran it again. I was able to investigate the stack traces of their failures. I found that it was an issue with using Japanese fonts that I hadn't previously been aware of, and I was able to fix it and ship a new APK to them to be able to test the app. So that was great, and that helped me without getting on a plane and flying to Japan to, you know, figure out what the problem was. But think about how this could also help you with your app, that you've deployed it to the Play Store, you've deployed it to the App Store, you're getting one-star reviews, you don't know why. Now you can see the crashes, you can see the impact, you can see the stack trace, you can fix the bug, you can ship a new version, and then you can use something like cloud messaging, say, okay, here's the analytics of these, you know, here's the audience of people that had a crash, and send a notification out to them that says, hey, look, we've updated the app. The thing that was causing it to crash has now gone away. Here's a 10% discount on any future in-app purchases, something along those lines. So then you can start turning those one-star reviews back into 3, 4, or 5 stars. The next one is hosting. And again, it's a small thing, but it has a big impact. Usually when you need to deploy an app to the Play Store or the App Store, you need a website associated with that app, which means you need to go to all the bother of getting web space and a domain name and building a website and mapping it and blah, 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 all that kind of work that you'd have to do. So we said, let's try and take some of the friction out of that. So if you have a Firebase application, you can set up Firebase hosting as part of that application. You can upload your files into storage that we provide, and you can map a domain name to that. It's going to be edge cached. It's going to be fast. You can have custom domains associated with it. I'm going to give a little demo of that. So a hobby of mine that I do is I like to do 3D CGI stuff and 3D CGI rendering. And so the biggest picture that I could render was a 10,000 by 10,000 image. So that's 100 megapixels. So I uploaded this to Firebase storage. We're on conference Wi-Fi where it's shared now. How long do you think it would take to download and view that image? Anybody guess? A few minutes? A few seconds? Should we give it a try? The Wi-Fi is really good. Okay, let's see. Boom, there it is. It's a 100 megapixel image like that. Okay, I cheated. So the idea is that in this case I used there's a JavaScript framework called Seadragon. And what Seadragon does is that if you get a really large image like this one, it chops it up into tiles at different zoom levels. A little bit like the way Google Maps works. So when you zoom in and out like of the satellite view of Google Maps. And I'm seeing my own tweet on the screen in the background, so I'm getting really distracted. So the idea behind this, like this was a JavaScript library. And so I used the JavaScript library to chop this image up into tiles. And so now that I'm really zoomed out, we're probably seeing like 400 by 400 pixels. That's why it downloaded really quickly. But while I've been talking, it's been downloading all the other tiles in the background. So if I start zooming in, for example, like this character's eye. So if I start zooming in on her eye, you can actually see the reflection in her eye, and that was what was behind the virtual camera when I rendered this image, just to show like this was a 100 megapixel image. You can see the detail in her eyelashes and all those kind of things. And when you do 3D CGI, like a lot of the time you'll design characters, but then you buy skins, and skins were made like by a professional photographer photographing a model, so you get real human skin in it. And the detail on this one was so great that if I zoom in on her fingernail, you can actually see the model had some dirt under her fingernail when the photo was taken, which I think is kind of funny. I don't know if she was aware of that. So that was done on Firebase hosting. So in this case, I cut the image up into those tiles. That my 100 megapixel image was cut into about 8,000 tiles. I put an HTML page. I used the JavaScript library. I uploaded it to Firebase hosting, and I was able to get that kind of performance out of it. So next up, and this is one of the newest things, and when we first shipped Firebase last year, every year we have a conference called Google I/O. Google I/O 2017 is coming up next month. We shipped Firebase at I/O 2016, and when we first shipped it, there was one thing that was really missing that a lot of people were asking us for, and that was like, it's great all this stuff that we've built, and it's great all this stuff to prevent us writing code on the back end, but sometimes we need code on the back end. Sometimes we need code to occur. Like, for example, the number one scenario that people asked us about was like, when a database value changes, how do we send a notification? And we'd have to say, well, you'd have to write your app, or maybe you'd write like an orphaned app that listens to that database, and when it sees a change in that database, then it would use Firebase notifications or Firebase Cloud Messaging to send a notification so that everybody would receive it. And that was a massive, massive hack to be able to solve that scenario. So we've been working pretty hard for the last year on this thing that we call Cloud Functions for Firebase. We released it in beta just last month, so we're continuing to build on it. But the idea of Cloud Functions for Firebase is if you think about a type of event that will cause a trigger to happen, like a change in a database, a change in an auth state, any of those kind of things that would be impacting things that are happening in your application, then a number of these are available as triggers. And with Cloud Functions for Firebase, the idea is that you write it's Node.js that we're using at the moment. We are working on other languages. But you'd write some Node.js code that you would save into Firebase, and then we would handle running that for you. So you're not managing a backend yourself, you're not managing a server yourself, you're defining an action to happen in the event of a trigger. You're using Node.js to do that, and then Firebase does the rest for you. So like I said, the two biggest ones that we heard were a database value changes, I want to notify my users. So the idea is when the database value changes, you'd write some node.js that talks to Firebase Cloud Messaging that will then send a notification to the relevant users. And the other one is like, for example, if a user signs up for my application, I want to be able to send a notification to them, or maybe a notification to somebody else that this user has signed up. And instead of writing all the spaghetti code for that or having an orphaned app to do that for you, the idea is that that would be a trigger that happens within the Firebase infrastructure, and then you script that trigger using Cloud Functions for Firebase. So those are the things that we've built for the developers, and so these are the services. You can see the idea is not to replace your APIs for building iOS apps or your APIs for building Android apps, but just to enhance them with all of these services. So next up comes when you want to grow your application. So to grow your application, there's a number of strategies that anybody can use, and number one is like friends help friends discover great apps, and so we want to make that as easy as possible for you to do. So I have a 16-year-old son, and my 16-year-old son is awesome. And what he does, and what he spends way too much time doing when you talk to his mom, is that he cruises the Play Store to find games, usually free games, and he'll play them for a little bit, and if they're good, he'll tell me about them. And that's how every game that I've ever played on mobile I've discovered. Now, we realize that that doesn't scale. Not everybody has an awesome 16-year-old son who will do that. But what we can do is that we can build an API for app invites, so that if you use these app invites in your application, then in this case, instead of him calling me and saying, go to the Play Store, download this game, it's called this, try it out, that you just have a widget in your application that can be used to share with me what that game is and take me through that entire workflow of installing it. And so now the idea is like, okay, that's great, but how many contacts do we have in our phone? Can we apply some intelligence to this? Can we apply some machine learning to this? And the answer to that was yes. So underpinning this is some machine learning and some stuff that we've been working on in Google for the last few years that pretty much says that in this scenario, he usually shares games with me. I usually install those games. So instead of me being halfway down his contact list, when it comes to him sharing a game, I should be at the top of his contact list. And his mom, who says he plays too many games to begin with, would be at the bottom of his contact list. So instead of just a dumb list of contacts being shared, there's actually a lot of machine learning going on behind the scenes, so that when you have this widget and you drop this widget in, you're taking advantage of that, so that when your users want to share with other users, it's reducing the overall friction, because the ones that are deemed most likely to install will be at the top of the list. It's built on something called dynamic links. And dynamic links in Firebase are really interesting because we wanted to build something that will allow you to maintain the session and maintain the context throughout the entire session. So if I give an example of, say, I have a friend who likes to cook and who discovers a great recipe in an application, say, for example, a recipe for lasagna, what's the workflow usually like? It's a case of she'll call me up and she'll say, hey, download this app, and there's a great recipe for lasagna in it. And I'll say, well, what app? And she'll say, oh, it's the recipe app. And I'll go to the Play Store and I'll find 500 recipe apps, and I'll ask her which one. After 10 minutes of figuring out which one, I go and download it, and then she says, yeah, it's the lasagna. Well, there's 500 recipes for lasagna in this app. And there's all of this friction that we had to go through. At any one moment, we could have dropped off. So the idea with dynamic links is in Firebase, you could build a dynamic link so that in this case, if she has this recipe for lasagna, and I don't have the app, and she shares the link with me using an app invite or using even just like using email or whatever. Now when I click on that link, or another example for this is if you put it in an advert where it's really powerful. Now if I click on that link, what's going to happen if I don't have the app? Typically you're taken to the Play Store, and a really smart thing will give you the page for that app that you would install. But Firebase Dynamic Links will actually remember the context of that link. So if I then install the app and launch the app, I'll be taken directly to that recipe that was actually shared in. So the idea is to totally reduce the friction, or reduce it as much as possible. And again, use analytics for insights about which ones work, which ones don't, all of those kind of things. Next up, and another one of my favorites, and one that I find tragically underused, is app indexing. So a common part of everybody's workflow is using search on their mobile phone. And if you're searching for content and you already have an app that has that content, shouldn't you be taken to the app to render that content instead of taken to a random set of websites that you may know or you may not know around that content? Because you've already made the decision to install that app, you've told the world that you're interested in that type of content. So if we're going back to my recipe example, so if I'm using the Google search app on my phone and I'm searching for a recipe for lasagna, but I already have an app on my phone with 500 recipes for lasagna on it. Like I said, instead of having a list of blue links for websites, wouldn't it be great if I could launch the app directly to see a recipe for lasagna? And that's what app indexing is all about. It's very simple, actually, to do, is that if you have the website with the content and you have the app, there's a file that you upload to the web called assetlinks.json in Android. Forgive me, I can't remember the iOS equivalent, but there was one that you can use to link to an iOS app as well. And then when the Google Spider crawls the website, it will say, hey, this content is available in this app. And now if the user is using the search app on their device and they query Google for that kind of content, then it's actually returning, you know what? Here's a set of websites with that content, but this app also has that content, and this app is on the user's device. So we're going to put that near the top of the list. And we're going to allow the user to be able to open that content directly in that app, directly from search. And that's what app indexing, that's what it's all about. It's really, really cool, and it's really easy to implement. Notifications, nearing the end, I think this is last but not least, is very similar to cloud messaging, and it's built on the infrastructure of cloud messaging. But the idea is that it's a simple UI with no coding. It's more aimed at like marketing people or those kind of thing, that when you use Firebase, you have a Firebase console. And the idea is that you can pick and craft a message that can get sent to your users. And that message can then be based off of analytics. So for example, if your application is really popular in the UK, but it's not very popular in Ireland, you can say, hey, look, looking at users in Ireland who aren't making any app purchases, but users in the UK are, then you have like a tool in the console that you can say, pick this audience, send this notification to them, and maybe offer a discount that you'd plug into the remote config that I was talking about earlier on, again, without writing a single line of code. So, that's a summary of what's in Firebase. That's a summary of all of the products in Firebase. Part of the future of Firebase, and one of the things that we're working on, is really the Google Cloud Platform. We've been, part of our strategy for, going forward in 2017 and beyond is we hear from developers that scalability is paramount. And scalability is often misunderstood. Scalability, people tend to think that means you can get really big. But really what scalability is about is being able to grow really big when you need to and be able to shrink back down to be really small when you don't need the scale. And if you're managing these spikes as efficiently as possible, then you're reducing your costs. So that's a lot of the work that we've been doing on the Google Cloud Platform and by extension in Firebase so that you can manage scalability very, very effectively. So quickly to go through some of the features of the cloud platform that Firebase is built on and that we're working on. Cloud functions. Earlier I spoke about cloud functions for Firebase. These are built on cloud functions which are part of the Google Cloud Platform. Lightweight events-based microservices. They're completely serverless. You're not managing any kind of server infrastructure. Automatic scaling when you need it, going both up and down. I like to give one example. There's an app that I worked on a couple of years back, and it was actually my very first app that I worked on when I joined Google, and I thought this was a hazing process. And it was for a boy band called One Direction. Anybody heard of them? And One Direction were launching a new album at the time, and they wanted to do a YouTube live stream. And at the time, it was the biggest live stream in history. But every 10 minutes on this live stream, they wanted to tell all of their users to go to the web to answer a question. And they were going to use this to discover who was the world's biggest One Direction fan. So think about this if you're building and maintaining that website, right? You have millions and millions of rabid fans watching this stream and not on your website. And then in an instant, when the band tells them to go to the website, they're going to your website. So you have traffic for zero, and then suddenly you have a spike where you have millions of users. And then they answer the question on the website and they go away. Now, think about how you would manage that scale. You really want it to look like this, right, where you've got lots of tall, skinny spikes. But in pre-cloud architecture, you would have to build capacity for this, right? So above the tallest spike, but then all of that space underneath your capacity that isn't part of a spike is wasted. And as a result, you're spending a lot of money for servers that are sitting there idle and you're not using them. So we built this and we used like a precursor for cloud functions, and we used App Engine to do this, where the idea was like saying, okay, let's see if we can emulate these spikes as closely as possible. We had to we used Python, we had to very carefully craft the app so that it wasn't doing hostile things for database writing and all that kind of stuff, and did a lot of stuff in memory cache and all that kind of thing. And so we ended up running this event for I think it was 11 hours on one day. So a question every 10 minutes for 11 hours, millions of users accessing it, tall, skinny spikes like this. Can you guess how much it cost if it was built efficiently? Anybody take a guess? Anybody think it cost more than $50,000? Nobody. Okay, more than $20,000? Okay, well, how much do you think? 1,000? 5,000? Okay, pretty good guess. I usually ask people, some people think within the 30 to 50,000 range, so you're a much better developer than they are. All I can say is that I'm not allowed to share how much it costs, but me and a couple of other people who worked on this went out and had a few drinks after the event was over, and our drinks bill was higher. And I don't even drink. So it was, I do a little, but so it was it ended up, when crafted very efficiently for scaling so that you can scale up and scale back down. And that's one of the attributes of the cloud platform that I'm most excited about, is that if you architect your application carefully, you can build massively scalable things, and they really don't cost a lot. I'll give you a clue, it was less than $100. So Compute Engine, just to wrap up, is it's virtual machines in the cloud. So if you want to have an actual operating system, if you want a Linux machine, if you want a Windows machine, those kind of things in the cloud, then you can do that VMs running in the same infrastructure that handles all the scalability that I was talking about. And then finally, the container engine. So Docker and containers, as we know, are red hot. We have a thing called a container engine that uses that. I'm not much of a container engine user myself, to be honest. But to give one example of where I found this really, really handy was in my lightning talk earlier, I spoke about the little robot that I built in Linux. And so the code that ran on that robot for geolocation, I did on my Linux desktop, and I ran it and I tested and it worked great. And then I deployed it to my Raspberry Pi-based robot, which also runs on Linux. The code didn't work. Because apparently the version of Linux on the Raspberry Pi used a different version of AWK than I used on my desktop machine. And I had to go through a whole lot of dependency management and installing a whole bunch of stuff on the robot in order to get it to be able to run the same code that I had run on my desktop. But that's the magic of containers, right? So if I had built in a containerized system, then I could have virtualized all of that and saved myself a lot of headaches. So again, we've been building all of this in the cloud, and that's the container engine. So Firebase is this suite of products that we've been building to help you follow the habits of the highly successful developers. We launched it last year, and hopefully this was a little bit of a vision into why we did it, into what it is, and into where we're going with it. So thank you very much.